Hey everyone, and welcome back to Build, Create and Learn a Maker's Journey. I'm your host Stefan, and in this episode we are talking about the big steps forward in my drone telemetry project. Last time, you might remember, I made the decision to pivot, leaving behind the SD card frustrations on my STM32 and moving over to CircuitPython on the Adafruit Feather RP2040. That was a big choice, and I wasn't totally sure how smooth things would go. But over the last 2 weeks, this little board has been an absolute breeze of fresh air. Today I want to share how I got my new setup running, why it felt more like building with Lego than wrestling with firmware, and how I'm already logging real sensor and GPS data directly to an SD card. We will also talk about my deliberate decision not to solder everything down yet and how I'm switching gears into the mechanical side of the project, designing an enclosure that can actually go on the drone. A quick reminder, if you want to see the code examples and photos of my breadboard setup, I've put everything into a companion article on my blog. The link is in the show notes so you can follow along while listening. So let's dive in. Part 1. A fresh start with the RP2040. First, the basics. I ordered the Adafruit Feather RP2040, and before writing a single line of code, I had to figure out which development environment do I want to use. I'm comfortable with PyCharm. I've used for Django and other projects, but for this I wanted to start with the community's lead. Most people recommend starting with the MU editor. It's lightweight, free and works across platforms. When I opened MU for the first time, I had a déjà vu moment. It looked a lot like the Arduino IDE. And maybe that's intentional. It's simple, just a few buttons, but it does the job. Setting up the board was surprisingly easy. I downloaded the latest CircuitPython UF2 file, held down the reset button on the Feather, and the board popped up on my PC like a USB stick. I copied the file over, the board rebooted, and suddenly I had a new device called CircuitPy. Inside there's just one file, code.py. That's where your program lives. Here's the magical part. You don't compile or flash anything. You just write Python, hit save, and the board reboots instantly to run your new code. It's such a different experience compared to the STM32 workflow where you have to build, upload, and cross your fingers. Part 2. Blinky and a rainbow. Naturally, my first test was a Blinky app. A couple of lines of code, hit save, and the little red LED started blinking. That felt good. But then I noticed something else on the board, a big RGB LED in the center. I had expected that one to blink, but it didn't. A quick look at the docs taught me this wasn't just a regular LED. It was a NeoPixel capable of showing the full spectrum of colors. I loaded up another example and suddenly the feather was cycling through the rainbow pattern. I showed this to my daughter and her eyes lit up. She doesn't care about GPIO pins or SPI buses. She just sees magic. And honestly, at that moment I felt the same. That's when I knew this was the right pivot. One thing I really want to highlight here is the Adafruit documentation. It honestly feels like they went the extra mile compared to many other platforms. Every page has clear wiring diagrams, example code and even photos. It almost felt like building with Lego. You just follow along piece by piece and before you know it, things are working. And that's not just great for me, it's what makes this whole ecosystem so beginner friendly. If someone told me today they want to get started with electronics, I would point them to the Adafruit boards over Arduino, simply because the documentation lowers the barrier so much. It takes away the fear of I don't know where to start and replace it with hey, I can actually do this. Part 3. Adding the BME 280. With the basics out of the way, it was time to bring the first sensor, the BME 280 environmental sensor. Adafruit's documentation made it super easy. You just drop the library into the board's lib folder, wire the sensor and run the example code. At first I hit an error. The board wasn't recognizing the connection, but a quick helper function showed me which pin were actually being used. And once I explicitly set the SPI pins, everything's come to life. Suddenly, every 2 seconds, the feather was streaming temperature, pressure and humidity data to the serial console. That's one of these little wins that keeps you going. Part 4. Facing the SD card again. Next came the moment of truth, the SD card. After all the pain from the last episode, I had a bit of hesitation. I wired up the Adafruit microSD breakout board, 5 connections in total, and tried the example code. At first, I got nothing but errors, but then I noticed the example was using a different library, SD card IO, not the one that I first tried. Once I swapped it out, everything clicked. I was able to save a test file, open it, and see that it had actually written to the SD card. Honestly, that felt like victory. After weeks of banging my head against the wall with the Arduino shield, this just worked. And it got even better. I quickly modified the example to log my BME280 sensor readings as a CSV file. At first, I was just appending everything into one log. But then I realized why not create one file per day. This way, each drone flight has its own dataset. Much easier to keep things organized. That was a real milestone, my first working telemetry logger. Part 5. GPS on board. The last piece of the puzzle was the GPS. I wired it to the Feather, forgot one connection, a classic mistake, but once I fixed that, I started seeing NMEA strings come through. And with the Adafruit GPS library, I didn't even have to write my own parser this time. It handled everything. Within minutes, I had a clean, formatted GPS data coming into the console. Adding that into my logger was straightforward, and just like that, I had environmental data and GPS coordinates logging straight onto the SD card. Looking back, I couldn't help but wonder, why didn't I just start here? Part 6. Maker's choice to solder or not to solder. With everything running, the next big question was, how do I mount this thing for a test flight on my drone? My first thought was to solder everything onto a perf board, and I still think that's a viable step, especially if you have a lot of loose components. But in my case, I'm using breakout boards for almost everything. They are already neat little modules with mounting holes. So I made a deliberate maker's choice. Instead of spending hours soldering, I will focus on getting a flight-ready prototype quickly. I can always come back later and build a more polished perf board and even a custom PCB. But right now, momentum matters more than perfection. Part 7. Switching to the mechanical side. This is where the project shifts gears. Electronics are one thing, but now I need an enclosure. Something that holds the feather, the SD breakout board, the sensor and the battery, and keeps everything stable in the vibration of the FPV drone. As a trained mechanical engineer, this is my comfort zone. Honestly, it felt refreshing to fire up a CAD software again and start sketching ideas. I tried a few paper sketches first, but quickly realized I needed something tangible. So I 3D printed some simple standoffs and a rough case to play around with the layout. I even embedded threaded inserts into the standoffs so I can screw things down securely. The first version was just hot glued into place, but it gave me the freedom to move components around until I found a good layout. The next version I will model directly in CAD. It's funny, while looking for inspiration on YouTube, I noticed that a lot of makers with purely electronics backgrounds struggle with enclosures. That's where my multi-skill approach really shines. Combining electronics, CAD and 3D printing feels natural to me, and it's one of the reasons I love these kind of projects. And maybe the best part, this sets us up perfectly for the next big milestone, the first real test flight. Part 8. Wrapping up and what's next. So where I am now. I've got the Adafruit Feather RP2040 running with CircuitPython, the BME280 sensor and GPS model are logging data, the microSD card finally works, saving everything as a daily CSV file, and I started designing the enclosure that will hold it all together. The next step is the big one, mounting everything into a case and strapping it down to the drone for the first real test flight. That's where theory meets reality. And honestly, I can't wait. If you want to see the code examples, breadboard diagrams and photos of my setup, check out the companion blog article linked in the show notes. And if you would like an even deeper look behind the curtain, project I tinker with that I don't always make it into the podcast, consider subscribing to my Maker's Logbook newsletter. It's a weekly peek into my workbench where I share experiments, half-baked ideas and lessons I learn along the way. Thanks for listening, build, create and learn a maker's journey. And if you enjoy following along the ups and downs and aha moments, please subscribe wherever you get this podcast. Let's keep building, creating and learning together.